Hello, everyone, and welcome. Thank you for joining us for this session on low carbon concrete. As you get settled, a few reminders before we get started. Please use the Q&A section for any questions today, and remember to be constructive in any of those questions or comments to the presenters and to one another to ensure that we have a session that is productive. Also, AIA California will submit one AIA HSW learning unit for those who complete the session live. And as always, the webinar content and additional resources will be available online shortly after the session. Today's session focused on how project teams can successfully establish and execute sustainability goals is brought to you by National Ready Mix Concrete Association. This session qualifies for one AIA HSW learning unit for those watching live. AIA California staff will report those units for you once you have finished the session in full. Today, you will be hearing from Luke Lombardi, PE, who is a sustainability consultant for Burrow Hoppold, Dave Walsh, AIA, owner of Dave Walsh Consulting, and Brandon Ray, who is the Director of Building Innovations for the National Ready Mix Concrete Association. Thank you all for being here today, and Brandon, I'll hand it over to you.
Perfect. Thank you, Rebecca. I appreciate everyone joining us today. We got an awesome lineup of experts in this industry, and Luke and Dave and myself have worked together for many years now, trying to promote low carbon concrete, that concept, and how we can transition projects into a state of actually achieving and realizing significant measurable reductions in carbon impact. So hopefully today we can highlight some bits of information that will help you on that process, on that journey. We understand that this is, really should be a full day course. So there's going to be a lot of maybe high level information or just transitioning really quickly through things that might seem to glaze over. But we do have a lot of resources out there that I'll try to highlight as well that you can connect with us and really get on the right track going forward. But to kick things off on our end, I do like to highlight, how our industry has progressed and, kind of where we are and where we've been and kind of where we're going. This is just a quick highlight. In 2009, we adopted a general industry reduction goal of 30% by 2030. That was just us saying, hey, we want to reduce our impact. And that was, quite a ways ago. In 2012, we were an adopter of Architecture 2030 Challenge. So that was, setting up a reduction of 50% carbon footprint reduction by 2030 and embodied carbon neutrality by 2050. In 2014, we did launch our EPD program and publishing benchmarks in our LCA report for concrete because, we can't reduce what you don't measure is kind of the notion there. So setting up this program as, a program operator in an association that really, our members are comprised somewhere around 60 to 70% of concrete placed in North America. We have access to a lot of data. So pulling that together and putting into these reports, and we've published multiple iterations of them over time, and I'll highlight that as well. In 2016, we launched Build with Strength, which is kind of where I'm housed. It's a grouping of architects and engineers and experts that are just here as a free resource for the industry to help educate and also how to, establish improvements and specifications, those types of things. And then in 2021, Roadmap to Carbon Neutrality, that was, a partnered program with our Portland Cement Association, really publishing where we are and how we're going to get there, that type of thing. And from that report, this is just a good visual to identify one, concrete production in terms of volume and the anticipated projected volumes over time. So where we are today, it's interesting to note that, the mass migration of people in this city centers and metros and those types of things, and just the need for constant building. The best plan is always going to be to reuse, repurpose, that type of thing. But inadvertently, we're ultimately always going to be building new things, and concrete volume is projected to increase. Same with cement production, but we're hoping to reduce the carbon intensity of concrete over time. So that's that right graphic you see there today versus 2030, 2040, and 2050, and so on and so forth. All that put together, with our LCA report, from 2014 to 2021, we did record a measurable decrease in embodied carbon for our industry of about 21%. And we're about to launch the next iteration of that report here in the coming year. So we'll see that even drop further. Present day, our industry, has well over 70,000 EPDs generated. So environmental product declarations for concrete specifically. Other materials have a much smaller quantity there. So we've been really making a name for ourselves in that regard. The report itself, the benchmark reports, this is just, again, some back information. You may have experience with this. If so, great. If not, you'll definitely be crossing paths with it in the near future. We publish a report, we take in producer data, and we look at what does a typical concrete mix look like in certain regions. And then we also proportion industry-wide EPDs. So our original report in 2021, or not the original, but the most current version, 2021 version 3, has something like 72 industry-wide EPDs. So it's based on different cementitious combinations. But version 4 is coming out here in 2024. We'll have more industry-wide EPDs, so a broader spectrum of options there. But then also it will have more specific regions. We went from in 2021 to from I think it was 8 regions to a more spread out parsed data into smaller regions and even possibly metro focused regional reports. So this is for your benchmarking and understanding, hey, what are we comparing against for our actual project? So be on the lookout for that as it comes out. Lastly, just to, like I mentioned, some resources here. Check out our website. We'll have all these documents here. Top 10 ways to reduce concrete's carbon footprint is a great strategy. Presentation and educational guide. We have our guide spec as well that highlights on, the transition to a performance-based specification. These are all going to help you on this journey. And really, the last thing I want to highlight before handing it off here to Luke is just a quick touch point on an important piece of information for setting the stage. Where does the carbon come from when we talk about concrete? Concrete is an agglomeration of, many different materials and ingredients, right? It's like a cake. There's not just flour, there's water, there's sugar, there's all types of things, right? And so with concrete, it's just the same. And here on the left, you see a breakdown of volume in terms of aggregates making 70%, water, cement is only 10%. But when you look at the actual carbon impact of each individual ingredient, and this is for a standard roughly 4,000 PSI mix with no SCMs, you see that cement, although being 10% of the volume, it's around 80 to 90% of the actual carbon impact. So that's just a good important piece of information to highlight that where we're dividing and focusing our efforts, and something that our presenters here will also touch on. So I'll hand it off to you, Luke, and we'll contribute from there.
Great. Thanks so much, Brandon. Yeah, super excited to be here with Brandon and Dave to talk about a topic that's near and dear to my heart, low carbon concrete. Yeah, so my name's Luke Lombardi. My background is in structural engineering, and I'm now a sustainability consultant with Bro Happold, and I sit in Los Angeles. And I'm going to start here just talking about, why are we here? What is, share my experience of what is motivating people. And personally, I got into this through SE 2050, program that is engaging structural engineers to kind of own their role and global greenhouse gas emissions. And I'm sure many on this call are familiar with other programs and similar, AIA 2030. Even mechanical engineers have their own decade as well now, and there's been a ton of great momentum around embodied carbon. And through this, we're starting to see more and more companies too also form commitments like science-based targets initiatives. As more people track and measure embodied carbon, or even just scope 3, or like the purchased goods carbon, it's becoming more and more apparent just how important a role it plays in industry decarbonization. And another major driver because of that, I'm sure people are starting to feel maybe a little bit of the heat or a little pressure to pick up this topic, is all around policy, right? There have been a number of buy clean policies that have come into effect in recent years at the state level. If you want to learn more about that, Carbon Leadership Forum has a great map that you can track those. And shout out to Dave, who's been doing a bunch of really great work, advocacy work in the Pacific Northwest, as well as we're starting to see both local and state level whole building LCA requirements. Thinking about, Vancouver and Toronto have both passed requirements for whole building LCA. And here in California, CalGreen has just recently passed a measure starting next year that you will be required, and I'll talk about this a little bit more, but to complete one of 3 pathways to be compliant considering embodied carbon. And then the last major driver that I've felt and I've seen reflected in the industry too is just generally around the ethos. I think everyone has seen kind of the news and what's happening around the world, and taking it our agency as designers and owning that role, that we have a significant impact in our professional careers, and really both a responsibility but also an opportunity to be part of that decarbonization. A little bit more about CalGreen. So it's exciting. Just you're probably going to hear this ad nauseum in the next several months because it's a pretty short window to getting people upskilled. But starting July 2024, if you're building in California, non-residential, over 100,000 square feet, or schools over 50,000 square feet, there will be requirements to meet one of three pathways: either reuse or prescriptive pathway, which is similar to a buy clean. It sets limits on carbon intensive materials, or completion of whole building life cycle assessment to prove reduction on your project. There's going to be a ton more about this, so definitely keep an eye out with AIA and SEOC and others. But before I go any further, if there's one thing I want you to take away from this webinar, is really this topic is all about collaboration. It can be very overwhelming. There's a ton of rabbit holes that we could go down, and like Brandon said, this could be an all-day workshop, but you are not alone in this. And one of the, I think, sort of empowering things around it is really just like being able to have the curiosity and humility to ask questions. I don't have to know everything about mixes, like set time for concrete or pumpability, because I have people like Dave who you can reach out to. So it's very much a team effort, and I know there's going to be a ton of information today. Hope you can go back to this for reference, but really want to empower everyone to just use this as a launching pad to have more conversations, and not be overwhelmed by what can be feel like a large new topic. And so with that, diving right into it, people may have a wide range of experience doing LCA, but at the various highest level, it's relatively simple, right? We're tracking our material quantities. It's very important to have a very tight, good numbers. All of this is contingent on having good data, and that's one of the reasons it's really important engaging folks like structural engineers when you're thinking about the structural embodied carbon, to get building quantity materials, and then we're just multiplying by what Brandon was talking about with the EPDs, like global warming potential factor. So if we have a cubic yard of concrete, that's going to have on average a certain intensity from the manufacturing process primarily, but also transportation, where that aggregate's coming from, where the energy is coming from. All of these things distill down into one number, which is a GWP number. And then we take in aggregate all of those materials for the building, and that's how we get our life cycle assessment. And I'm not going to talk too much about design in this webinar, but suffice it to say, it's very important. Just we're thinking about it's all driven by materials, right? So early on in the design process, the material efficiency is highly dictated by just the systems you're using, the column span, the grids that the building has. And this is a sensitivity study done by Burrow Happold. It's out of the UK, but the physics and all the concepts apply. And you can see by controlling each variable, you can see one of the biggest control variables we can have is just by the floor system on the right there. We can have, there are other impacts too, of like not being too overly conservative and design loading, trying to have consistent grid size, and not having long spans or significant cantilevers can be a big driver for additional material quantity. But all of those factors, again, in collaboration, working with a team, can be estimated early on in process, design process, to guide us towards more efficient systems. And the other really big driver, which I think we will talk more about it because it's specific to concrete in this conversation, is really around mixed design. So GGBS in this diagram, that's slag in UK speak. And so really driving towards, how can we think about our mixed designs in a way that can be more efficient and lower carbon. And so when we're thinking about this on the building scale, we start by, once we get through, schematic design, we may be comparing different scenarios. But as we move into DD and have a pretty good sense of the envelope and material quantities we're working with, we can understand, what portion of our overall embodied carbon is coming from each material. And specifically talking about concrete here, we can also think about, what applications, each application will have its own mix design, right? It might have different strength requirements or durability requirements. It might have different impacts to schedule or pumpability. All of these variety of characteristics means we need a tailored approach to each of these mixes. But if we know the proportion of the overall contribution, then we can have some sense of what percentages we're playing with, right? So if we can reduce 10% of of something that is 50% of the project, we have a 5% overall reduction, right? And that's important when we're thinking about our overall goals. And as we get this, our baseline set up, then I think it's really important to start that collaboration process, right? I'm going to keep reinforcing that, but we can there are a lot of free, easily accessible tools at our disposal now. EC3, something I use pretty much every single day. There's a very nifty new feature that just came out, I think recently, is you can develop a project, and now when you search, you can set a radius within your project and even see the different manufacturers, ready-mix suppliers in the region, and you can see what data is available to make those informed decisions. So going back to the project example, we can look at our floor or we can look at our foundation. We can search by that strength, and we can also lay out some other design criteria. Very important, I will also say that this all comes with some asterisks, right? The data that is available in EC3 may be somewhat skewed based on maybe some optimism bias. It doesn't search by application. So if I search for 5,000 PSI concrete, it doesn't separate mixes that have been applied for floors or foundations or even sidewalks, right? But it can give me a sense of what is the range of impact that I can expect given mixes that are even specific to my region and my regional ready mix suppliers. And I should also take one step back and just say that baseline, looping back to Brandon's initial comment, that baseline is set by those inter-MCA industry averages. So what is a typical strength that I'm using for my project? Very excited for the next iteration of that, Brandon, and more regionally specific averages. But in our case, this is where we start the conversation. And we're particularly lucky here in California, but also places like New York, very rich in EPD and lots of data. It sort of depends where you are regionally, but EC3 is a great tool to just understand what ready-mix suppliers are already providing EPDs. Not that you shouldn't engage and try and get more ready-mix suppliers or ready-mix suppliers who haven't, whose EPDs are not on EC3, but it tells you which parties you can start to have that conversation with. And as the design progresses, you can start to apply this to your goals of the project too, right? Like, are we trying to meet CalGreen or are we trying to meet LEED? A 10% reduction is sort of something that's been somewhat standardized by LEED for better or for worse. But we can look at, where can we have the biggest influence? And you'll see something that's common is floors are almost always the biggest proportion of our material, right? And so that's something where we can really try to dial in both the design, but also see what we can do in mixed design, because that's the biggest portion. However, there may be places where we can ramp up greater GWP reduction because of other design construction considerations, right? Like a foundation might be a place where we can expect more reduction because there aren't the same schedule requirements or finishing requirements. The design strength isn't going to see the design load for much longer. Things like that, where we can have this conversation as a design team to see how we can optimize. And that's the key piece, right? One of the biggest things that the first question I ask when I get pulled onto a project is, is there a general contractor engaged? And I try to start that conversation because they're the ones that probably have the biggest influence, right? Like they're the ones purchasing, they have the connections with the supply chain. And I try to write a little introductory email and talk about the goals of the client, goals of the project, and set up design charrettes and just get an understanding of what ready-mix suppliers are in the area. If I can have a conversation with mix suppliers specifically, we can talk about what is your SCM supply chain? What is the availability? Is it seasonal? Do you get Portland limestone cement? So like the checklist of things that we know can reduce embodied carbon in concrete, we can talk through those and make an assessment. What are the risks and what are the contingencies that we need to make to meet our sustainability goals? Do we need a different mix design in the winter because it's cold? Can we talk about loosening up a traditional 28-day break strength for certain elements? And where we formalize this, right? Ideally, you have a conversation and you can solidify some of this in your project documents, your specifications, your drawings, and there will be more discussion around performance-based specs in the rest of the presentation. But this is where hopefully that communication gets solidified and it becomes part of the requirements of the project. Again, Brandon and Dave will talk more around like concrete GWP budget approach and all that, but just to say this is something that's key for effectiveness on the project. And all of this discussion, all this collaboration, it's really steering the industry towards better practice. It's how can we as structural engineers specify what we need and not restrict the design for better optimization of global warming potential or other characteristics that are important. And I think there's a lot of mutually beneficial aspects of this. Something that we've been working on transitioning here in California is just getting structural engineers to make sure that they write in their specs that they can allow Portland limestone cement. And there's good data and a shift towards the industry with that. And I think there will only be more innovations and other aspects that we will need to continue to collaborate and move faster because just because the pure timeline that we need to make changes for climate is relatively short. I'm probably over my time. Like I said, we have a lot to cover, but just in closing, I want to touch on, because it's always something that comes up, but cost. And there is industry research as well as anecdotal experience. And again, I encourage you all to talk to folks who are in the field and actually doing this. But there seems to be great potential, in the range of 15 to 30% reduction in concrete possible without necessarily impacting cost or schedule or those things. And I'm sure Dave can talk more about that. And I also flag that right now we're there's a lot of industry research and it continues to be dynamic. Things will continue to change, but I expect we'll have to meet those baselines. Might change in the future. It may change from the building itself, which is fairly common practice now, to more standardized intensity limits, and we can imagine that will continue to get more and more stringent as the decade moves on. So, Dave, I'll hand it off to you. That was fast.
All right. So again, glad to be here. Luke, thank you for that presentation. My name is Dave Walsh. I'm an architect and worked many years in the design field. And then most recently was the Director of Sustainability of Selling Construction in Seattle, where I'm based. So today I'm going to talk a bit about how contractors and design teams can collaborate, a little bit about procurement, but also what can be done before and during construction to reach the carbon reduction goals on projects. So I'm going to start with those very early decisions in a project that can put projects on the pathway to maximize their carbon reductions, but also have an impact on constructability. So starting with the when of carbon, as many folks probably know, the International Standards Organization has divided lifetime carbon into various life cycle phases, A through D. And this is the so-called cradle to cradle. A lot of the focus and conversation is around upfront carbon. So that's that life cycle A. And within that, a lot of the focus is on EPDs, which not always, but most frequently cover just that A1 to A3, which is the so-called cradle to the factory gate. So you might think that, today we're talking about concrete as a material and embodied carbon, that, really A1 to A3 is really all the story. But I would say that even before anything is manufactured or brought to the job site or placed in a building, there are very important design decisions which have a lifetime impact on carbon. And so I'm thinking about things like those program decisions. What is the owner asking in terms of flexibility requirements? And how does the need for flexibility drive things like the bay sizing, which drives span lengths, and all of that rolls up into material quantities and embodied carbon. Obviously, your engineering choices, what kind of structural system, how is the lateral system organized? Are there efficient load paths within the building or a lot of transfer slabs? All of those things too can have significant impacts on embodied carbon. And then towards the end of the project, how things go together, but more importantly, how things come apart in the end, ties directly to that last life cycle phase D's. Because if things don't really come apart in a financially feasible way, they're really not going to be recovered, reused, and recycled and reduce the embodied carbon of that next project. So once you've decided, that concrete is the best fit for a given project, the next decision is what kind of concrete system, whether flat slab or slab on metal deck, or maybe a post-tension system. Each one of those systems has a direct carbon and constructability impact. And so, as I mentioned before, each different system will have differing relative quantities of materials, and with that, differing relative quantities of embodied carbon. Your contractor might be thinking, with a given system, can I do a strategic trade-off? Can I intentionally use a higher strength concrete, which may have more global warming potential lower down in the building, so that as I rise up, say with the columns, I can go to a leaner mix and have an overall reduction in embodied carbon. Your contractor will also be focused on those tricky areas. Where does, say, rebar congestion necessitate a highly flowable concrete like self-consolidating concrete, which has both a carbon and price premium over conventional concrete? And then, as always, constructability issues. Your contractor will be focused on things like the heat of hydration and how the various concrete systems affect that constructability need. So the type of concrete system, some systems are more schedule sensitive to others. And I'm thinking in particular about post-tension decks. And those have a very tight schedule need. They have a need to have a tight pour cycle so that it will support the overall critical path of the project. And so when you have to support the pour cycle, you need to reach an initial strength fairly quickly, sometimes between 1 and 3 days, to support that overall schedule. And so your contractor is wondering, what is that? I'll call it the Goldilocks mix, the mix that meets that initial strength so you can stress your tendons, but doesn't have excess carbon emissions. Also, your contractor might be thinking, what are the other elements in your project, the other applications, maybe a mat slab or a foundation that will receive the live load later on, and maybe the maturity date to reach that full design strength can be extended beyond the traditional 28 days. So column layout, span, and lateral systems all contribute to embodied carbon. I think that some of these decisions, are obviously not discretionary decisions. Sometimes your site is what it is, or your program demands those long spans. But what I would suggest is that if you do have a project that has some flexibility in maybe the aspect ratio of your floor plate, or the spans don't always need to be those long spans, these are great opportunities to have material savings, and with that, have a design impact on reducing the embodied carbon. So things that you might not immediately associate with greenhouse gases, like aesthetic decisions, can play a role. So the desire to have a light appearing concrete, or the desire to have polished concretes, can influence your mix choice. So for example, if you wanted a light appearing concrete, is your contractor going to have to source white cement from, perhaps the other side of North America and incur those transportation emissions? Or would it be acceptable to use a supplementary cementitious material like slag that has the advantage of having a whiter appearing concrete after it's cured? Things like polishing, sometimes I've encountered where we're being very ambitious in terms of reducing embodied carbon. Maybe we're using a new mix, and yet you don't want to go so low with taking cement out of a mix design that you have a failure when you're polishing and have a rock top. So this all speaks to the importance of having time in the schedule and money in the schedule to do mock-ups. So what can be in the specifications that enable your contractor the tools to reduce embodied carbon? When I think about specifications, I think that they really need to do basically three things. First, they need to be performance-oriented and not prescriptive. So tell me what you want, not the recipe on how to get there. And this is very important for design teams, because if you're overly specific, if you frankly give exactly the recipe, how much cement, how much this, how much that, and something doesn't work out, your contractor might say, hey, we did exactly what you told us and it didn't work out, and maybe that's not our issue. The second thing that specs need to do is they need to allow for multiple options with the ingredients. So multiple types of blended cements, multiple types of supplementary cementitious materials, multiple options with both aggregates and admixtures. And then lastly, the specs need to be very clear about, what are the carbon reduction requirements, not to sort of generally, maximize reductions as much as possible, but very specific and quantifiable, and be very clear that, hey, do you meet these reduction goals with, a portfolio of multiple materials over the entire project, or is it something specific to concrete? And then when you set your reduction goals, be clear about what kind of baseline you're looking for, what kind of documentation in terms of EPDs or bill of material reporting. So a few do's in terms of performance-oriented criteria. There's some things that you should let your general contractor determine and to manage. And so they are responsible for the schedule. So they need to be the ones that are determining when that initial strength is needed to support their schedule. But on the other hand, they're the ones that are in best position to say, hey, for this application, maybe we can extend reaching that design strength, that F'(C), beyond the traditional 28 days. Your design or your contractor team should also be the ones determining the min and the max of the cement content, the type of supplementary cementitious material, and constructability characteristics such as slump. A few don'ts, obviously don't go back into the archives and copy a prescriptive oriented specification into a new project. Don't limit the type of allowable cement to just the traditional type 2 and type 5. And also don't require a certain minimum percentage of SCM replacement. I'll talk about this a little bit later, but that's really the wrong way to go about that. Also, importantly, don't peg a specific value for the water cementitious ratio. This is important, but you can let the requirements of ACI 318 be your technical guardrails to give you the quality, and also avoid a situation where if you were to peg that specific water cementitious value, it could take some good solutions off the table that would otherwise meet the requirements of the project. So real briefly, I'll just talk about blended cements and what they are, and very, very high level. When you're making cement, limestone goes into one end of the kiln, and at very, very high temperatures, there's a chemical reaction called calcination. This is the moment that most of the CO2 related to cement is released. And so with blended cements like Portland limestone cement, also called type 1L, about 10 to 15% by mass does not go through the kiln, and so it doesn't have that chemical reaction. And so right off the top, you can do a 10% reduction in greenhouse gases just by specifying and using that type 1L cement. It does have a long track record. It's been used successfully since the 60s. It's cost neutral in many markets. So the takeaway with all of this is when you're doing your specifications, allow multiple types of blended cement, not just that, type 1L, but the 1S, the 1P, and the 1T, in addition to specifying your more traditional, ordinary Portland limestone cement. When you get to your concrete spec, 03300, point back to the front end, to your designable or your sustainable design specification, where you'll lay down kind of the rules of the road, what kind of baselines are you going for, a certain rating system, et cetera. But when you get to 03300, be very clear about, what baseline you're using and what is the reduction requirement. That reduction requirement should be in part 2, because that's just another kind of performance criteria. If you are requiring EPDs at the time of bid, please do your homework and make sure that multiple bidders within your market already have those EPDs published, because you don't want to be limiting competition on your project. So getting back to the topic of, why you should not specify a minimum percent by mass of SCMs or supplementary cementitious materials. You can see in these two examples, they're both 5,000 PSI mixes. One reaches it very quickly, the other takes a little bit longer. But by mass, they both have 25% supplementary cementitious materials. But if you look down at the actual emissions, the kilograms of CO2 emitted per a cubic meter, there's quite a difference. So the right way to express a reduction target is to pick a baseline and then say that there's a reduction by a percent below that baseline, not require a certain percentage of SCMs by mass in a given mix. So lastly, I'm going to just touch on a few things that your contractor can be doing in pre-construction and in construction. One great thing, and Luke mentioned the importance of collaboration. I really couldn't agree more that during design development, if you do happen to have your contracting team and your supplier on board, is to have an embodied carbon concrete workshop. And so, include obviously, architect, structural engineer, your general contractor, your concrete contractor, and your concrete supplier if you have them. This is a great time to talk about, what are the relative quantities of each application? What is the general contractor seeing in terms of typical business as usual reductions? What kind of schedule needs are there? Is there a tight pour cycle? And frankly, what makes people nervous? And what are the strategies to sort of address these concerns? And then from this, come up with a sort of short list of targets and reductions for each application. I see that contractors, during the design process need to expand the role from just doing cost estimates and building a cost model to building a carbon model. So they need to become a carbon forecaster, and maybe it's using a tool like EC3 that Luke mentioned, or some other tool. But this is super important because a contractor needs to understand, where is the carbon in our project, and what are the big movers. So when they're doing the buyout and they're selecting a successful bidder, they're not just paying attention to carbon for one material, but all the areas that are significant in the project. So constructability, important for everybody, but there's some constructability issues that actually align with embodied carbon reductions. Addressing the heat of hydration is one of them. And so for these, you need to be looking at the areas that are large volumes of concrete, which will generate a lot of heat when they're curing. But using things like slag or fly ash can retard that heat, retard the curing, but also help you use less cement and have less GHG in those mixes. Reaching early strength, that's kind of the sort of opposite challenge. Again, thinking about those tricky applications like post-tension concrete slabs, finding that mix that, will support, getting those stressing of the tendons early, but also not blowing your embodied carbon budget. Things like colder weather can frustrate these issues, and sometimes using things like maturity meters that measure the heat of the curing concrete, which tells you in turn the strength, can help you fine tune the right, most carbon efficient mix for the season. How concrete is placed, whether it's pumped a long distance, whether it's shotcrete, each one of those will determine not only the ingredients that go into the mix, but also the carbon intensity. So be aware that different methods of placement can have an impact on the carbon intensity. And then lastly, finishability, always an important issue for everybody on the team, especially the contractor. Some of the desired characteristics may tip the scale to one sort of supplementary cementitious material, such as fly ash has the advantage of having almost a more creamier mix in terms of improved workability. Slag, as I mentioned, has the advantage of curing more white. But as always, just want to stress again, what happens in the lab with a test cylinder is not what happens at the job site. So if you are breaking new ground, trying new mixes, being aggressive, please make time for having in situ mock-ups to make sure that it is addressing all of your project needs. So with that, I will hand it over to Brandon.
Perfect. Thank you, Dave. Yeah, no, I'll second that, this collaboration discussion that we're having, and we're talking about trying to maybe try things that maybe are a little new or different for certain contractors or certain projects, and early age collaboration is always going to be, where you allot yourself that time to do the mock-ups, do the trials, collect the data, get comfortable with it. If you're, showing up the day of bid or whatnot, wanting to procure low carbon concrete, there are things off the shelf, but your best case scenario is always going to be, again, allotting yourself that time to get it done. So next up here, I just wanted to touch on a few things. I wanted to give an example. I think I alluded to at the beginning here. We have a new carbon tool that does help in this process. I find that there is a lot of ambiguity in exactly how to ask for and receive this infamous, low carbon concrete, LCC. How do you get this? And the simplest way to look at it is to set the stage by allowing for producers to put forth their specific low carbon solutions, because as you've probably deduced so far, not every producer is the same. Not every region has the same materials, all these types of things. So it gets very finicky if you're trying to go in and explicitly prescribe, use this cement, use this much SCMs, those types of things. So the goal really is to set the stage by allowing all these different strategies. If they are available, they can be implemented without any inhibition from the specification. And then it also allows for flexibility and execution with the contractor in the field, because again, time of year, schedule considerations, that's all going to be key as well. And so we all know, we've all been on projects, as-built conditions almost always differ from the actual original plan design, right? So this kind of follows that same ethos. So when, the project team needs to set a target that a producer and contractor can strategically work towards, on the target side of things, NRMCA has developed this tool. So I'll highlight a quick example here, but I do want to fly through, collecting the data that goes into that. So first thing is going to be, defining our sandbox a bit. primarily looking at transition to say, step one, performance-based improvements, improving the specification to accept these strategies, accept these materials. We're looking at the, the book specifications in the project manual, and we're also looking at the structural general notes. And then also two, looking at, okay, now that we've cleaned up the specs or set the stage for these materials to be effectively procured if available, step two is going to be establishing those carbon targets and carbon accounting, essentially. And so trying to trigger the use of these materials. So on that step one, performance to prescription to performance, with these performance-based improvements, the goal is simple: to make that transition. Some of the tools that you might consider are shown here on the side. We have our guide specification to ready-mix concrete, and it's, master spec format. It shows all the different things that are pertinent to, procuring and installing successfully concrete, but also allowing for these different strategies as they are available. And we also have a guide on specifying performance. So if you want to go, if you're an engineer or working with an engineer, there are other things that you can specify that can even override certain exposure class requirements by actually having testable metrics that you adhere to. But the key overall through this whole process is really adhering to very religiously your exposure classes for ACI 318 exposure classes. So for the different conditions that the concrete is exposed to, you want to, there's going to be prescriptive criteria to ensure performance. That's the purpose of the code. But we want to make sure that these prescriptions are not applied to all concrete and all applications, or carried over from one project to the next. Being exposed to freezing and thawing, in one application, but all of a sudden that same mix is going to be, is intended to be applied to an interior slab. You don't want those same limits, because there's going to be water to cement ratio limits. There's going to be SCM limits potentially, and all these other things, and strength limits that really force the mix to evolve into something that it necessarily doesn't need to be. So there are other things to consider. If you are trying to control shrinkage, look at not putting in water to cement ratio limits for that, but actually specifying the shrinkage percentage, or deflection, stiffness, looking at MOE of the composite mix, and not just specifying, again, higher strength and lower water to cement ratio, thinking that's going to get you the modulus of elasticity that you need. So there's a lot of different things that you can do, and it's a whole other presentation as well. So feel free to loop in our team of experts and our engineers, and we can do that as well for you and help guide that process. But the results of this whole, process is really going to be getting efficient and optimized mix designs. That's the key. Not just doing business as usual. This is the mix I've always used. This is what I'm comfortable with, but more so focusing on an efficient use of the material. Luke touched on, efficient design, sizing of columns, grids, spans, eliminating excessive transfers or cantilevers whenever appropriate. So, incorporating that with an efficient mix design, it's kind of your 1-2 punch to get you where you need to go. So as I mentioned, the one thing about performance-based specs is that they allow for sustainable mix designs and processes, but they don't require it. That's kind of the point of the performance-based specs, is that they allow that flexibility and testable means. And so really, at the end of the day, what this does mean, and in regards to sustainability, is that if you don't ask for sustainability, you're not going to get it. So a clean performance-based spec is going to open the door for a lot of different strategies, but it doesn't force the hand of certain materials and those types of things. So this is where the carbon accounting and targets comes into play. Instead of specifying specific strategies, we want to set targets that trigger the use of low carbon ingredients and methodologies. This begins with, collecting your environmental product declarations, and builds off the adage that you can't reduce what you don't measure. I mentioned that earlier in the presentation. Critically, we want to encourage asking for product-specific EPDs when available, but also allowing for industry-wide EPDs, as both can be powerful in establishing and achieving carbon goals. Our industry-wide EPD is not, like other industries where it's an agglomeration of everything, and it's one EPD that's trying to encompass every single mix. That's not the case. We actually have a matrix of 72 industry-wide EPDs, and those products and cover all different types of cementitious combinations and are much more accurate. And with these EPDs, we can then establish a carbon budget that comes, it becomes the guiding, mile marker for the entire project as you're trying to, transition towards a low carbon project. And when you get to the end of this process, this results in the procurement of low carbon concrete, and more importantly, flexibility for the contractor and producer, to allow them the time or availability to implement certain strategies that might be more beneficial to the schedule, less on sustainability, but they make up for it in other applications such as foundations, that type of thing. And also a buffer for as-built conditions. As we all know, there's going to be variability there. So, specification first and foremost, resist the temptation to set carbon footprint limits for individual classes of concrete. There is a use case for this, but in effect, this is the same thing as providing prescriptive limits on materials, and doesn't really leave room for the contractor and producers to innovate and meet project performance requirements, including budget and schedule. Like I said, there's certain use cases where this is viable, particularly if you're really well connected with a producer and contractor. For a mega project, for instance, you guys can identify what those limits realistically can be. But typically we encourage a carbon budget, and that's going to be your more preferred approach, and it's taking the project as a whole is really what that's trying to do. Now, how that looks like, the budgetary approach is preferred, as I mentioned, to a piecemealed approach, largely because it does allow the project team to strategize and adjust mixes as needed to fit, variations in material availability, schedule demands. Do we need to accelerate certain slabs or certain columns so that we can keep the project on schedule? But then we're going to make up for it by having, much more significant reductions in the foundations or other elements. Doing 50% reduction against the benchmark in the foundations, great. You may have, if you did a prescriptive approach, you might have said, oh, for the foundations, we want 30% reduction, and maybe that's all you get, right? Well, maybe you can push the limits a little further, but that's really more so means and methods and up to the contractor and producer to delineate. And when you really look at it from, that high level holistic view, both of these routes, a project budget versus individual limits, can have the same essential, output in terms of total GWP. One is just, again, doing it prescriptively, and another is really allowing for setting the expectation, right, for the contractor and producer, but allowing for them to figure out how to achieve that. So to give an example project, I'm going to run through this here, and we got should have enough time. So, as previously discussed, the best approach is, to use life cycle assessment, and you may not seem to have, feel like you have sufficient experience in this, but it is relatively simple, and hopefully this will kind of portray that. Step one is always going to be to have a benchmark project, and that can be using, there's a lot of different benchmarks out there, or a lot of different beyond benchmarks. You can even look at requirements from municipalities, those types of things. But the benchmark project is going to be your baseline, and then you're going to be comparing against a proposed project. And so the benchmark for our example here, we're using NRMCA's Cradle to Gate LCA of Concrete report, various iterations, currently on version 3, as I touched on at the beginning of the presentation, transitioning next year to version 4. So that'll be, you're looking at for a certain strength, getting an actual typical impact there. And then in this case, you can use industry-wide EPDs, as mentioned, or you can use product-specific EPDs. So if you have them available via EC3 and you know how to use that tool and actually interpret the different applications and strengths, you can get an idea from there, or working with the producer and contractor to get the product-specific EPDs that you intend to use. And really, going through this whole thing, essentially for each instance, the benchmark and proposed, it's really a simple arithmetic. Once you've identified and tabulated the GWPs for each class of concrete, you're really just demonstrating this. You're just looking at, simple arithmetic. The volume times the impact, or times the GWP for that mix, is going to be your impact, and you total the impact for the project, right? And so you do that for a baseline, and you do that for, the alternative low carbon mixes. And to demonstrate this, I'm going to run through a very quick, just very high level example using a 18-story building here, breaking down, different elements, shear walls, columns, floors, basements, foundations, the different volumes. Our benchmark on that benchmark column there, that's pulled directly from the LCA benchmark report. You say, okay, 6,000 PSI, well, it's from design, but the impact will be from the report, but you allocate, okay, all the different strength classes. And then you would propose the different cementitious combinations, for instance, that might be used to achieve lower carbon. On the benchmark side of things, this is the actual report. When you look at it, you'll find, okay, for this particular example, say it's in Boston, we look at the Eastern benchmark. You identify there 6,000 PSI. There's the GWP. You got 305 kilograms of CO2 equivalent per cubic yard. That's your benchmark for 6,000 PSI mixes in that region, right? Next, you take the environmental product declaration. So in this particular example, looking at, say, a product specific EPD, you can scroll down there. There's a lot of different things on there, but the most critical thing that we're looking at for this particular example is the global warming potential. So in this case, this is a 4,000 PSI at 28 days, having 190 kilograms of CO2 equivalents. Keep an eye on units is something we always want to highlight as well. Looking at if you were to use the proposed industry-wide mixes, it's the same general report as the benchmark, but there's just a different appendix in there of the actual industry-wide. So you'd pull in, here's, as I mentioned, there's 72 EPDs for this particular example, looking at, say, 6,000 PSI in this example. You have the different cementitious combinations. Is there, is it 100% cement or very minimal fly ash or slag? The different cementitious from there in and there out. You can identify, okay, in this example for, say, it's a foundation, we'll do, or another element, a shear wall, we'll do 20% fly ash, 30% slag, for instance, and that's your mix delineator. And then you can then find that mix later on in the report and see the impact. So for that particular mix, 231 kilograms of CO2 equivalents. So after you've kind of gone through that exercise, you'll have all the different, classes of concrete or elements, the volumes, then you'll have the benchmark impacts for each mix, and then you'll have the proposed impacts for each mix, whether you got those from the industry-wide or from actual product-specific EPDs. One thing I do like to note is that the industry-wide currently only does look at up to 50% SCM replacement. If you happen to be in a region that does 70% replacement for foundations, which is a common practice in certain areas, you'd have to augment that with product-specific EPDs, or we actually in our tool can calculate that specifically. So the tool itself, is a great connectivity resource between NRMCA, who we're doing the, the benchmarking and the industry-wide, the producer actually producing the mixes or having product-specific EPDs, and then also the designer to help, navigate that process, and it's available on our website. It's really just a web-based tool, really interesting, simple, straightforward. The output from that is an actual simple report that itemizes all the different impacts. I won't spend a lot of time on this. It's the generic, input variables, typical stuff there, input the different metrics, but then you're also picking a specific baseline or benchmark. There's the benchmarks from NRMCA, there's GSA for their requirements, City of Portland, CLF. Also there, soon to be Cal Green metrics in there as well. If you're in California, those types of things. So it helps you navigate that relatively easily. Taking that previous, set of input data that we calculated, you put the classes of concrete, the different strengths, it'll populate the benchmark, and then you input the actual mixed GWPs, go down the list there. And another fun aspect of our tool is it does have carbonation included as well if you want. So there's a little quick analysis for service life, is it a 50-year service life, 60, 100-year? Is it a slab? Is it exposed? Those types of things. You check all those different variables off, and you can get a proposed carbon sequestration for those mixes. Once you go through the whole process, you really just output, a nice little report here. But the primary focus of the report is looking at your benchmark project, your baseline in this example, and then what the proposed project is plus carbonation. And you can see there, it might be a little blurry, but the difference from the baseline, you'll see, we have shear walls, 24% reduction, columns, 16% reduction, lower level floors that are accelerated maybe for high early strength, they only have a 4% reduction. Now, if you set a goal of, say, 20% reduction for all those floors, you're going to be in a scenario where schedule is going to be impacted, cost is going to be impacted, both, but with this particular example, we had, say, 45% reduction in the foundations, and it kind of offsets some of those areas of maybe more strategic, performance, I guess I should say. And really the aggregate reduction for that project in this example then is 23%. So that's a really good, reasonable target. Once you take that figure, we have our benchmark mixes, we have our proposed mixes, and we saw, okay, a 23% reduction is what we can achieve. add a little bit of buffer and additional tolerance in there. Let's set in the actual specifications a reduction of 20% as our goal, or a 240 kilograms of CO2 equivalents weighted average. And really, it's as simple as that. Putting those figures into your specification. Our spec guide does highlight other modes of verbiage that can go in there to pair with this, to marry with it. But that's really the gist of it for the most part. So it looks like we're at time. I did want to highlight really quick, our industry is constantly moving towards other innovations. We have cement innovations with alternative raw feeds, electric production, alternative fuels, calcined clays, other carbon sequestration with artificial limestone aggregates, recycled concrete aggregates, CO2 curing, and then mixed designs. We also touch on, strength enhancing admixtures, more efficient use of the material, and artificial intelligence is another thing that our industry is really getting really neck deep in. So a lot of interesting, exciting things out there. That's it for us. Looks like we're short on time for Q&A. I think we'll try to answer them maybe offline. Rebecca, you can let me know.
Yes, absolutely. So thank you guys so much. We are at time, so we want to make sure that we give you guys your 1 o'clock, hour to go back and do your thing. I want to thank Luke, David, Brandon, thank you so much for being here. A very, very informative presentation. I know that we have a whole bunch of folks that are looking forward to taking the recording once it's finished and going back through with, a lot more time on their hands to go through each of these specs and everything. So thank you again. Thank you everyone for joining us. We will go ahead and post the LUs, the HSW for each of you who have made it this far. We'll do that automatically for you. And we will also answer these questions offline and send them in a follow-up email with additional information and resources for all of you to have and take home. And that's it from us. Thank you so much.
Thank you.
Thank you.
Bye,
Yeah,
everyone.
lots of information. Please, everyone, keep the conversation going with your
Definitely.
engineers, contractors, ready mix suppliers. Please reach out to great resources here. Hope everyone is able to take some good information well.
Bye, everyone.
Bye.